Okay, so what's up mga Auranians? Now we are in the last part of our example or last example for our methods of sections for trusses. Okay, so you have here your truss system subjected to the following loads: 25, 15, and 5 kilonewton 5 pounds at point D, point F, and point H as shown in the figure. Next is your required is to determine the actual force acting on member EJ. So member EJ is over here. Okay. So most likely, if you were to pass a section wherein one of which is your required, okay, so most likely that particular section would be this section. Okay. Now you might be thinking you may project this line upward, then this one also upward, this one upward, and then the point of intersection somewhere above would be a point of intersection or point of moment. Okay, and then in that case you have two unknowns for that particular equation, and then you may proceed to the last remaining two equation, but of course you would still have an excess unknown. Therefore three equations is three, and three unknowns is or cannot answer that particular section. Okay, so what we can do is to strategize. Okay, you can strategize by going back to the principle that you can, or going back to the the principle that you can take moment at a point wherein all of or majority of the forces are uh, intersecting. Majority of the forces which you do not need intersects at a single point. Okay, so majority, let's say at point F. Okay, that would be a point of intersection for this member and this member. So if you were to utilize the upper section using this section, utilize the upper section, then you would be having a moment equation wherein that is your point of moment. You have two unknowns, okay, CE and EJ. Now if you know the value for CE, then you can calculate the value for EJ. Okay, so maybe first thing that we need to do is to determine the value for CE such that that particular moment equation at point F can be our solution to determine the value for EJ. Okay, so first let's have a solution to determine the value for CE. Okay, now for CE, this is like the K-truss which we have in the previous example. You can pass a section here, 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 and here. Okay, so if you pass your section here, 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 and here, here, okay, then you can expose the actual forces acting on this member CJ and then this member DJ. Okay, and then they would be collinear. You can take moment at point D, then you can directly calculate for CE. After calculating for CE, you can go back to the previous section. Okay, so let's have a recap on what are we going to do. Okay, so ang recap natin is you take this section. First step is take this section, then take the lower part. Okay, calculate CE. After calculating for CE, then you can calculate EJ by taking summation moment at F. Okay, I think that's clear. Now, first things first is your reactions. Okay, so for your reactions, you have here a roller support at A. Let's have your reaction here. Let's denote that one as VA. That would be vertical since your contact surface is horizontal. Next is you have here a hinge support. That would be on the downward direction since there is no vertical forces other than VA. So since VA is already assumed to be vertical, let's assume that the vertical component of the reaction at the hinge B would be downward. Let's denote this one as VB. And then you have also your horizontal reaction at B. Let's denote this one as HB. Okay? Okay. Next, we can now take, or first things first is need to determine the values of your reaction since you involve the lower and the upper sections of your truss. Okay, so first taking summation moment at B is equal to 0. let's take positive clockwise. Okay, on the clockwise direction, you have VA. And then counterclockwise, you have 5, 15, and 25. Okay, so you would have here VA. Lever arm for VA is, you have there 3 plus 8 plus 3. That would be 14. Next, minus, you have 5. Lever arm for 5 is 6. Next, you have plus, or sorry, that should be minus, or that can be retained plus, as long as you place a bracket here. That is plus 15. Lever arm for 15 is 12. And then last plus, you have 25. Lever arm for 25 is 18. Okay, it's just a matter of proper grouping symbols. Okay, so calculating for VA, you would have how much? That would be what? 5 times 6, 15 times 12, 25 times 18. Sorry, 18 divided by 14. That is, let's just take the fraction. That is 330 over 4. Okay? Pounds. Or hashtag. Or whatever that may be. Okay? Next is taking summation forces vertical is equal to 0. Let's take positive upwards. On the upward direction, you have VA. On the downward direction, you have VB. No more forces along the vertical axis. So, therefore, you can conclude that VA is equal to VB. Then, therefore, VB is equal to 330 over, sorry, that should be 7, over 7 pounds. Okay? And then last is summation forces horizontal. That should be equal to 0. Let's take positive going to the right. To the right, you have HB. To the left, you have these 3 loads. So you would have here HB is equal to, you have 5 plus 15 plus 25. So therefore, HB is equal to 45 pounds. Okay, so I think that's very clear, no? Okay, next is to take that section. Okay, so if we were to take this section, that one, this one, this one, and this one. Okay, so let's erase this one to better visualize the forces which you are dealing with. Okay, erase, erase, erase. Bura, bura, bura. Nakakamiss mag-lecture sa blackboard, ano? Anyway, hindi pa kasi mawala-wala yung COVID na yan. Okay, so you would have here your actual force. Again, these are assumed directions. You have here CE. Next, you have here CJ. Sino si CJ? Hindi ko siya kilala. Next, you have here DJ. Sino si DJ? Hindi ko rin siya kilala. Next, you have here FD. Sino si FD? Food and drugs. Joke. Hindi ko alam. Anyhow, going back. Stop with the jokes. Okay, so if we were to take moment at D, you can directly calculate for CE. Okay? Next concern is, before we calculate for that one, CE is inclined. So, basically, what we can do is to express CE in terms of its components. So, CE can be broken down into its vertical and horizontal components. Okay, so what we would be needing is the pitch. Okay, so you have here, this triangle here is similar to this big triangle. Correct? So basically, this one is 3, this one is 18, so the ratio would be 1, and then 6, and then the hypotenuse would be 1 plus 36. That would be the square root of 37. Okay? Okay, so next. So taking the lower part, okay, the lower part. Don't disregard this one. So we're just considering, let me enclose this one for us to better visualize the part which we are analyzing. Okay. Okay. So this is your section, lower part. So taking summation moment at D. Summation moment at D is equal to 0. Let's take positive clockwise. Okay? So if you take summation moment at D positive clockwise, on the clockwise direction, you have here VA, that is on the clockwise direction. You have here CE, clockwise direction. Next, VB, that is also in the clockwise direction. HB is on the counterclockwise direction, correct? And then these forces here are not included. Basically, they are at the point of intersection, including that 5-pound load. Okay? Next problem is your lever arms. Okay? So, by simple analogy or by simple analysis of ratio and proportion, so this one is 3 feet. So, therefore, this distance here from this point to this point, if you try to project that one, that would be 1 feet. And then if you try to project that one here again, that is from here to here. If you try to project this one downwards, and also this one downwards, okay, that would be 1 1 1 1 feet, 1 feet, 1 feet. Okay, same is true on the other side. Okay, if I were to project this one, kulayan natin para masaya. You have this one. It's basic geometry. Then, and then, yan. Okay. So this one is 1 feet, 1 feet, and then 1 feet, making 3 feet. 1 foot pala. Anyway, engineering. Okay, so going back. Taking summation moment at point D is equal to 0. Let's take positive clockwise. Clockwise muna tayo. Let's have CE. CE times vertical component, that would be 6 over the square root of 37. Lever arm with respect to point D. Okay, so you have here 2 feet plus 8, that would be 12, plus 2 feet. Okay, let me repeat it again. With respect to D, you have here 2 plus 8 plus 2. That would be equal to 12. Okay. Next is clockwise. Next clockwise would be plus. You have there VA. Lever arm for VA with respect to this one. If you try to project, you have here 2 plus 8 plus 3. Okay? So that would be 13. Next clockwise is VB. Correct? Okay, so VB would be, if you try to project VB on that particular direction, you have your lever arm VB for VB, that would be 1 foot. Okay, and then on the counterclockwise direction, you would have HB. So minus HB. Lever arm for HB is what? 6 feet. Okay, that is equal to 0. Okay, transpose to the other side of the equation, all of these variables which we have already identified their values, we can calculate for CE. Okay, so let's have this step by step. 6 over the square root of 37 times 12 is equal to, you have their positive HB. HB is 45 times 6. VB becomes negative, so minus VB, or what is VB again? That is 330 over 7 times 1. And then last, you would have what? You have minus VA. What is VA? That is 330 over 7 times 13. Okay, so CE now is